Welcome back. This is problem number 16 of exercise 6.5. Okay, I am going to read out the problem. In an equilateral triangle, prove that 3 times the square of one side is equals to 4 times the square of one of its altitudes. Okay, he is giving that in an equilateral triangle. Let me consider an equilateral triangle first. Okay, A, B, C. This is an equilateral triangle, means all sides will be equal, of course. Okay, prove that 3 times the square of one of its side. What we need to prove is 3 times the square of one side, any one side we can assume. Let me take it as AB. 3 times the square of one side. 3 times the square of one side is equals to 4 times. 4 times the square of one of its altitudes. Means any one of its altitudes. Altitude is nothing but the perpendicular drawn from one corner to opposite side, right? This is nothing but altitude. Here it is perpendicular. Okay. One side is equals to 4 times the square of one of its altitudes. 4 times the, here altitude we have as, let me mark it as AD. Altitude is AD. 4 times the square, right? Means we have a square always. Okay. This is the statement that we need to prove. Well, since this is an equilateral triangle, we know that any line which is drawn from one point perpendicular to the other side will act as a median and will bisect this line into 2 equal parts. Means here we have BD equals to DC. Okay, that is the condition over there. Okay, consider triangle ABC as shown. Draw a line AD perpendicular to BC such that BD is equals to DC. Well, I am drawing a line AD perpendicular to BC such that BD is equals to DC. Okay, now we can see that this triangle contains 2 right angle triangles, right? Let me consider one of it. I will consider this because in this right angle triangle I have AB and AD, which are the sides that I need to prove, right? Those are the sides which are included in the statement to be proved. Okay, I will consider triangle ABD and apply Pythagoras theorem. Okay, well, if I apply Pythagoras theorem for the triangle ABD, AB is nothing but the hypotenuse and BD and AD are the opposite sides. Therefore, hypotenuse square AB square is equals to BD square plus AD square. Well, since BD is equals to DC, okay, I need AD, but however I need to eliminate this BD such that my equation contains only AB and AD, right? Therefore, I can write BD is equals to DC, right? Means it also implies that BC is equals to 2 times of BD. BD is nothing but half of this complete BC, right? Since both 2 are equal, therefore I will write BD as BC by 2. BD is nothing but half of BC. As you can see in the figure, or you can also write this as BD is nothing but BC by 2. If I substitute that parameter over here, I will get AB square is equals to BC by 2 whole square plus AD square. AB is equals to BC by 2 whole square plus AD square. Okay. Let me write it over here only. I will be getting AB square is equals to BC square is nothing but BC by 2 whole square is BC square by 2 square is 4 plus AD square. Okay. You can pause and copy. I will be continuing it here. AB square is equals to BC square by 4 plus AD square. Okay, well, until here we had got here, right? Now, since it is an equilateral triangle, all sides will be equal. However, AB will be equals to BC, that will be equals to AC, right? Okay, means AB and BC are equal. Instead of BC, I can write AB. Wow, well. Now I'll bring on this all the terms, AB terms, onto one side of the equation. AB square minus AB square by 4, that is equals to AD square. If I take LCM over here, I will be getting 4AB square minus AB square divided by 4, that is equals to AD square. Okay, 4AB square minus AB square is nothing but 3AB square, right? Okay. 3AB square. 3AB square by 4, that is equals to AD square, and 3AB square is equals to 4AD square. Oh, we have come up with the equation. Oh, two-proof statement has been missed, right? Okay, let me say that directly. B, D, C. Okay. It is given that 3 times the square of one side. 3 times the square of one side is equals to 4 times the square of one of its altitudes. 4 times the square of one of its altitudes. Well, we have come up with the equation. I hope you understood, guys. Well, thank you.